Okay, guys, so today what we're going to do is start kind of an introduction to hypothesis testing. So, the first question is probably what is hypothesis testing? And this goes directly along with our confidence intervals. And actually, confidence intervals are part of the test. So, a hypothesis test is when someone makes a claim about a population. Now, that claim could be related to a proportion or an average. So, for example, the claim in the news has been made that they speculate that, I don't know, 60% of US citizens will get the coronavirus. So, that's an original claim. So, the whole purpose of hypothesis testing is, let's say you come upon some claim and you don't think that it's going to be accurate. Say, I see that 60% and I think, oh, there's no way. I think it's going to be less. We're going to do our part and flatten the curve, and it's only going to be 35%. And, maybe we don't really know what the actual percent is, but we think that the original claim is wrong. So, if we think that the claim is wrong, then what we do is we say, let's test it. So that is what a test of hypothesis is. If you remember from science classes, a hypothesis is kind of like what somebody thinks will happen. So somewhere along the line, somebody made a hypothesis. We came across it and we said, no, I don't think that's right. So we're going to test it. So, to do that, there are three different types of hypothesis tests, and they go directly hand in hand with our confidence intervals. So, we have a Z test, a T test, and a one prop Z test. So, if you remember our confidence intervals, we had a Z interval, a T interval, and a one prop Z interval. The same guidelines apply for when you would use each one of these different types of tests. So, what kind of remember and summarize that, a Z test we would use when our population standard deviation is known. A T test is when sigma is unknown, or if your sample size is very small. And then a one prop Z test is used when somebody is making a claim about proportions or percents. Okay, so these go hand in hand with those confidence intervals that we've been talking about. So now the whole idea, the basics of how we conduct a test of hypothesis. What we're going to be doing is we're going to be utilizing something called the 5-step process. So what I'm going to do in this video is I'm going to give you kind of a brief rundown of the 5-step process. Then what I will do is I will follow up with future videos in more detail about the different steps and kind of putting the whole test together. I'm going to try to keep the videos pretty short because I know you guys don't want to sit and listen to me talk for an hour. Okay, so step number 1 is to state what is called your null and alternative hypothesis. Okay, so we'll talk about that in a little while. Step number 2, state your level of significance, which is something that is called our alpha value. So that's another one of our Greek letters, alpha. You may remember I mentioned it in the past. Step number 3, find critical values and test statistic. Step number 4, find what is called your p-value and make a decision. And step number 5, construct a confidence interval. Okay, so that's our 5-step process, and I will be referring to our 5-step process a lot throughout this. Every time we do examples, I will refer to the 5-step process, whether we're doing a test by hand or in the calculator. And there's kind of parts we have to do of both. We still will always refer to this 5-step process. Okay. All right, so getting started with that 5-step process. Step number 1 is something called your null and alternative hypothesis. Okay, so your null and alternative hypothesis. Your null hypothesis is what I like to refer to as the original claim. Okay, so that is that original hypothesis that you found somebody made a claim about something. Your alternative hypothesis is what we actually think to be true. Okay, so we've got what we think to be true. Now, there's some notation that goes along with these. The null hypothesis uses a symbol called H sub O. So that is the notation that we use for our null hypothesis. And the alternative hypothesis uses H sub A. So I like to think of this as hypothesis original, even though they call it null, hypothesis alternative. So that kind of helps me keep them straight. Now, a couple of other things about this. You notice after the H sub O, H sub A, I have a colon. That's because more information has to go with this. So it depends on if you're doing a test for means or proportions, what symbol you use. So if you're doing a test for means, somebody is making a claim about a population mean. So what we would do is use our symbol for population mean, which is mu. Now, they're going to make some sort of claim. I don't know. Let's talk about ACT scores at Paint Valley. Let's say that somebody says our average ACT score is only an 18. So they are claiming that the population of Paint Valley High School has an average ACT score of 18. Now, another thing that I want you to remember here, the only thing you will ever use in a null hypothesis is an equal sign. That's it. Only ever use an equal sign, okay? Now, what we want to do is we want to make a claim. We want to kind of counter this claim. So let's say we don't think it's 18. So we always use the same symbol. So we have mu. And then we also still keep that same number there. So we have mu and we have 18. Now, what we have here is we have a choice. We can either say that we think it is less than 18, we think it's greater than 18, or we don't know what it is, but we don't think it's 18. So less than, greater than, or equal, or not equal to, those are the only options that you have for an alternative hypothesis. And these things, it really matters because we end up with some different types of testing. So if you use less than or greater than, this is what we call a one-tail test. If you use not equal, this is what we call a two-tail test. And I'll explain a little bit more about that when we get into critical values and test statistic. So I don't know, just for the sake of this, I think it's higher than 18. So I would make the claim, my alternative is, I don't think it's equal to 18. In fact, I think it is greater than 18. Okay, so the first step is setting up your null and alternative hypothesis. And this kind of helps you set up, what your test is going to look like. You're determining now, are we doing a test for means or proportions? If it's means, we use mu. So test of means, we use mu. Test of proportion, we use a lowercase p. So that stands for population mean, population proportion. And we're trying to make some inferences about those. Your null and alternative also set you up for what type of test, whether it's a one-tailed test or a two-tailed test. And again, like I said, I'll talk about that a little bit more when we get into critical values. So step number 2 is your level of significance. Okay, and our level of significance is denoted by this symbol called alpha. So alpha has a direct correlation to your confidence level, okay? And typically what we do is we use alpha equals 0.05 unless we're told otherwise. That is kind of the standard in statistics that we tend to follow. Now, that should seem familiar to you because we've talked a lot about this whole concept and how this all goes together. 0.05 is 5%. Way back when we talked about the empirical rule, what do we remember about 5%? Your 5% is what's left over out here in these tails. Those are the things that we consider to be unusual. Also, 5% goes in a direct correlation with what? With 95%. So that means we want 95% to be in here. That 95%, this now corresponds to 95% confidence interval. So the alpha value and your confidence interval go hand in hand. So if you run a statistical test with alpha being 0.05, you have to run a 95% confidence interval. If you run a test where alpha is 0.10, that's 10%. So guess what confidence interval you run? A 90% confidence interval. So those two things go directly hand in hand. Now, your alpha value also has another meaning. It is related to something called error, which is going to be a whole separate video that I'm probably going to post next before we go on further with the other steps. But this is the first little video in this series. It kind of gives you, it gives you a little intro into hypothesis testing, and we'll get a little further in this as we go.